Good for her.
Cameras on.
No, my papa said that if somebody come this house and get a gun, he gonna shoot it up in the air. And if you run fast enough, maybe you don't get caught. But if you get caught, it ain't his fault.
All right, here we go. Chemistry.
Can I make these diatomic molecules?
What?
Can I make that diatomic molecules?
That's what they are. All right, so on the left-hand side of the board of 7 diatomic molecules. All right. They're Lewis dot structures. Lewis. I don't.
Yeah.
Oh, yeah. Was he one of those that was like really a physicist, or was he like an actual chemist?
Okay, so these are the 7. Notice that the first 5 are all single bonded, right? Notice that what we have here are the 4 halogens and hydrogen, and we said yesterday that hydrogen and halogen were interchangeable with each other, correct?
Yes.
The only difference is hydrogen's not going to have any lone pairs, and the halogens will each have 3 lone pairs each. Okay. Other than that, they look the same. Oxygen has a double bond. Okay. And nitrogen has a triple bond. There's a question in your practice questions that say something about which. Is that how it's worded? But something about which diatomic molecule has the highest bond dissociation energy. That would be nitrogen, because the triple bond is the stronger bond. So it's going to take more energy to break it.
Highest bond association.
Did you
How do
say
you spell it? What'd you say?
I said highest bond association.
Bond association.
Yeah, so I was just repeating what you said.
Okay. Yeah. All right.
so did you say that triple bonds and like double bonds are shorter than single bonds?
Yes. So the triple bond in nitrogen is the short
And
bond.
shorter bonds are stronger.
Shorter and stronger, just like it's not the same as an ionic compound, but like an ionic compound, the smaller ions get closer together. That makes a stronger ionic bond. In the same kind of idea, but yet it's different how it actually happens, but the same kind of idea that the short triple bond is a stronger bond. The single bonds are longer and weaker.
Does that mean that the hydrogen would have the lowest bond association? Or would it be equal with all the
It
same?
would probably be iodine. Probably the largest, the smallest of these in terms of bond association, because the iodine atoms are large. That single bond is going to be pretty stretched out.
Okay. So iodine would be bigger?
Probably the smallest bondage. Okay, so that's the 7 diatomics. That's pretty much all there is to know about those. Okay, there they are. All right. Oxygen. This is oxygen right here. This is what we're breathing, right? So 21% of our atmosphere is oxygen. Okay, that's the form of oxygen that we take in. We have to use all of our metabolic processes and whatnot. 78% of our atmosphere is this nitrogen compound right here. Okay, that triple bond makes it very, very non-reactive. There are chemical reactions that can happen with N2, but they're very rare. All right, it makes it a mostly inert gas. Inert meaning it doesn't react. So we just breathe it in and blow it out. Your body has no use for that. Breathe it in and blow it out. Breathe it in and blow it out. Okay? Your body can't do anything chemically with that because it can't break that triple bond. That triple bond is very strong, as you said, and it can't break it. So there are certain bacteria that can break it down. Okay? And certain types of plants, beans and peas and stuff are able to break it down. Lightning can break it down. But most metabolic systems can't do anything with it. So,
I don't know if we've been over this or not, but why couldn't oxygen like have three lone pairs each and just have a single bond? And then why couldn't nitrogen?
because that's not the right number of electrons. You had 3 lone pairs on each one, but in a single bond, that would be 2 too many electrons. So right? So that's 2, 4, 6, 8, 10, 12, right? That's 14. Right. Yeah, so you gotta have the right number. Okay, so what we breathe that, but we don't use it for anything, okay? 78% of the Earth's atmosphere, 21%, the other 1% is argon, and then there's trace amounts of water, CO2. Other things.
I think I'm just losing a bit of where'd you get like you have to have 12 electrons from?
6 plus 6.
Oh, because the,
First step to drawing, right, is to come up with the number of valence electrons.
okay,
2 oxygen, 6 plus 6.
all right.
Yep.
If it asks, when we ask which one has the largest association, so we just go on for like, yeah, on the association, we just be CL since it's bigger. Wait, let me make sure. No, we'll be fluorine since it's bigger. Sorry, I didn't look.
Chlorine because it's smaller.
We'll be fluorine because it's smaller.
Chlorine atoms are smaller, so that single bond will be shorter than this single bond.
So,
So to make that single bond stronger than this.
so that we have a large, so we'll have a larger one.
All right, now, yesterday we mentioned the term allotrope, right? We were discussing 2 allotropes of carbon, graphite and diamond. There are several other allotropes of carbon, but those are by far the most common. So graphite and diamond are 2 allotropes of carbon that form covalent network solids. You need to know that, okay? Did you write it down yesterday?
I don't know, I'm just saying one
2 allotropes of carbon
Yes, we wrote that in.
are graphite and diamond.
Oh, I read that in.
In this covalent network solid, both of them, slightly different structures, slightly different properties. Yes.
Got you.
An allotrope is 2 pure forms of the same thing.
I thought it was.
Okay. Speaking of allotropes, there is an allotrope of oxygen. Okay. Ozone, which is O3. It's a second form of pure oxygen.
That's what makes the sun not burn us alive.
That absorbs ultraviolet photons. All right. So, take a couple of minutes and draw the Lewis dot structure of ozone. How many electrons are in ozone? Valence electrons?
18.
18. Okay. Okay. Did anybody have the idea to do this?
Just what I was thinking.
Okay. Let's talk about it.
One interruption. Students, if you have purchased a homecoming t-shirt and have not picked it up already, you can do so in Ms. Sweeney's room during 7th period. Again, you can go to Ms. Sweeney's room between 6th and 7th period to pick it up. Thank you.
Let's sell homecoming tickets today. Let's sell them again tomorrow.
No, it's just big.
Yeah, I think that's just.
What do you think?
You go online if you didn't do the stage.
Just go online.
Or you pay more, $2 more. $2 more on that.
It's not my ticket.
Yeah.
I got the text message. This is this morning. Please remind Jack to buy his homecoming tickets. Of course, I forgot.
Oh,
But I'm paying for it anyway. He'll remember himself. Like, I ain't going to homecoming.
send this one.
But there are tickets, like, I don't want to, not here. I wouldn't go right.
Yeah.
Yeah.
Oh,
So this one.
should be my last chaperone. Not coming to, I'm talking about just taking the kid. To go there, you know. Thank you. No, let's see, when will Elite Night be?
Oh.
So you're driving that?
February.
I'll have to do that.
That's so sweet.
You're chaperoning?
I'm driving them
He has a little
around.
day.
I'm not coming in the building if I can help it. That's my
Oh,
wife
he has
makes.
a little thing. That's so sweet. Who's he taking? Elite.
Alan girl.
Oh,
Avery.
that's so cute.
Homecoming and everything, yeah. Oh.
That's so
Avery
sweet.
Allen?
Yeah,
Oh. Oh.
so,
How do you ask
That's
her?
not
He just
little.
be like, no, that's your coming thing. Like a poster.
no, we don't do all that.
Oh.
That's the stupidest thing I've ever seen.
I like that.
It's elaborate request for.
That's what I'm saying.
It's homecoming, like I don't get married.
You don't understand.
I understand. I never went to homecoming by myself, and I never went to all that trouble either, so it's obviously unnecessary.
It's just a nice gesture.
It's just unnecessary. But I think I'll have to drive you to Elite Night. She said she's in February. She'll be driving in April, it'll be 16.
It'll be 16 already?
Unless it gets delayed.
Is he- isn't he in ninth grade?
It's May.
And he'll be 16 this year.
present?
I feel old.
My mother went there to go to school when he was young. How do you make it?
Wow.
And she drives.
No, have you seen that?
She's a art teacher.
Yeah.
So is her mother, several of her family.
That looks like-
members.
Trying to go to the left.
Profession.
Left.
And they were, boys are so much less
like
mature than
that.
girls.
Yeah, my brother
They
should.
do so much better
Yeah,
if
you know
they're,
what?
if they're older.
Yeah.
So he did 2 years of pre-K.
Me too.
Yeah, and then I didn't think she was gonna send him, but she sent him, but I found out, look, they're gonna come get you like. tomorrow, you know. So I'll send him on to school, but. Yeah, so he'll be 16, he'll be 19 when he graduates. That's the drawback,
Yeah, me too.
but.
I didn't know that. I thought that most of the ninth graders were like,
Yes, him and one of those Patterson boys.
So he's
Jack,
he's 2008?
Yeah, he's born in 08. I think for a little 08, I think Jackson Patterson born in January, February. So he'll turn 16 a couple months before Jack. But they probably don't do it over right now.
I'm 06, so.
Huh.
I said I'm 06. I know, like, a little bit older.
Mr. Cradle, have you ever seen Ice Age?
27.
That's one of those squirrels chasing
Do you
bacon
know
all over
Scrap? The
the
one
place.
who eats the. That's why. You turn your head to the left, the ozone makes
Turn your head a little bit.
Turn the head to the left. Looks like
He's like the eyes and the.
like the two eyes.
Y'all come up with weird stuff. All right, so
Yellow.
back to why this is the wrong answer,
Oh.
okay? All right, let's go back to why this might be, this is the wrong answer.
Wait, that's the wrong
This is the
answer?
wrong answer.
Okay, good.
I wrote that down.
even gonna write that.
This is the wrong answer. So usually, it doesn't have to be. Usually people, somebody in the room proposes this as a possible starting point. Here's the problem. This makes what shape? Triangle, specifically a equilateral triangle, right? Geometry class. What are the angles of an equilateral triangle?
Always
say
say
180. No, not 45.
45. Oh, equals 40.
Is that
You're just
90?
The 40.
3 sides make
45.
90.
45. 45.
Six.
Dang it.
6
Oh, wait.
degrees, right?
Oh, I knew it equals
Okay,
180.
geometry, very good. 60 degrees, so here's the thing, here's the problem with that. Right? If you think to that chart, right? Okay, you've got 109.5, 107, 104, There's 120 on there, okay? The 60 though, that's very small compared to this. There's a couple of 90s. When you get to the expanded octets, you can have some 90-degree angles, but those, nothing smaller than 90, all right? And that ends up being too much strain. So if you think back to, remember how we said those big atoms couldn't overlap their orbitals, right? It's kind of the same idea. So the orbitals are, if you think about p orbitals, they're all pointing in x, y, and z direction. If you're going to bond two things together, there's 90 is about as, twist that a little bit maybe, but to squeeze that all the way down to 60 is just going to overlap them, it's going to basically pop apart. So that's not viable. Now you can have some carbon atoms that do that, but under extreme conditions. But the reason that this would, I've never seen it ask this, but it would be a good question just to not put that on there and ask why does that not make sense? And it would be because the bond angle is too small. It can't be like that. Okay, so that's 4 electrons, right? We're trying to have 18. Okay. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, everybody pay attention to what we're about to do. What's wrong with that right there?
The middle one only has
Oh, the
6.
The middle one doesn't have an octet, right? So we got 6. How do we fix it?
You have to take
Start adding in
take
double
one.
Right?
Yeah,
Which one am I going to move?
the first, the central one.
Move it.
Oh,
This one?
yeah, I took away that one first.
Put it here,
Yes, I put it either way.
but it's still going to have 6 if you do that.
Yeah, and then I added another one.
No, you take one from one of the side ones and put
Okay.
it into a double bond.
How about this one over here?
Yeah.
Yeah.
All right.
Yeah.
Yeah.
Yeah,
I like it.
yes, that's what
Yeah.
do you know?
Yes,
Okay.
oh my God.
Now,
There are too many.
It doesn't matter which one you put on.
did anybody take one from the other oxygen on the right?
It's a resin.
What?
No.
No, like,
Oh, I
don't
remember
name
that.
like.
Remember this?
I remember.
Okay.
I just completely
The
forgot that they were
residences
allowed
that
to not
double
use.
So what if we had done this?
Yeah, it's the same thing.
Resin.
Resonance structures, yeah.
In other words, we took this pair and moved them down here. Would they both be correct?
Yeah, I did the second one. Yeah.
So they're both correct, right?
Oh, so then you want to put those like little dot things if you want to do it all in one.
We don't want to do that yet. All right, so here's the situation. Everybody pay close attention to this, okay? According to the rules, those are both correct, which means they're both wrong,
Oh, yeah.
okay? They can't both be correct. What, in actuality, what you have is a hybrid of the two. It's called a resonance hybrid. We symbolize that by putting this double-ended arrow between those two, quote, right answers, even though neither one of them are correct. What you really have going on here is this pair of electrons. Let's just take this pair of electrons. Everybody watch what I'm going to do. Everybody look up here. This pair of electrons goes here, okay? And this pair kicks off over here, and then they come back here, and then that pair goes back there. And that's happening continually all the time at near the speed of light in a very small space, okay? So what you have is two pairs of electrons that are delocalized, or that word the other day, okay? So you have here delocalized electrons. And that's called resonance. The delocalized electrons are resonating back and forth throughout the molecule. They're doing it so fast, and when you incorporate the idea there's only 90% probability anyway, and they're basically just all over the molecule all the time. Okay? And that's called resonance. The simplest way, here's the thought. The simplest way, in the way that the AP exam will want you to draw it, is to draw all the correct structures according to the rules and put those double arrows between them. There is another way to do it using dashed lines. I'll show you that one. This is not what they're gonna ask you to do, but this means the same thing. And I'll explain why this is kind of important to say. Okay. Now here's one reason that they don't ask you to draw it this way, but I kind of like it this way, because they will ask you this: what's the difference in the two bond lengths? Okay. According to this drawing, this one's longer and this one's short, right? Or maybe this one's long and this one's short. Okay. But in actuality, they're both the same size. Both these bonds are the same length, and they're shorter than singles but longer than doubles. They're hybrids of the two. Okay. But this molecule is not like Wappy-Jaw, right? It's not long on one side and short on the other. It's equal lengths. Both bond lengths are equal. Okay. A little bit shorter than a single bond, a little bit longer than a double bond. Okay. It's basically a bond and a half. It's like a 1.5 bond. Okay. Question that they might like to ask is to say something like, these two bonds are the same length. Why? The answer is because they're the resonance hybrids of single and double. All right, Grant, fire away.
Hold on, because I didn't even get it of a single and a double. Hold on, I didn't get this. You said these, what might they ask these two resonance structures are?
I don't remember.
These two
You
bonds
said
are the
hybrids
same
of,
length.
Single and
a
double.
single and a double.
Okay, so basically, my question was,
I think you don't even know your question.
my question is, so basically what I wanted to ask you is, so like, on the two, if you took away, like, two of the oxygen, you know, if you gonna take away.
So what? What's that mean? Took away two oxygens.
Like,
Well, they know the way to do it, except the way I did it.
I mean, but I'm wondering why,
Okay.
why would my way work? So I took away two of these, put those right here, I took away two of those and put those right there. That's what I was thinking.
The oxygen
Now, why
too much
wouldn't,
now.
like, why wouldn't I be able to?
You had two double bonds, that
Yeah.
puts 10 electrons on the one on
The
the right.
central one, and it can only have 8.
The one on the right would have 10 electrons. You move those top two over to the,
Can I like move,
just look, you move those top two to a double bond, that's 10 electrons on that right-hand oxygen, so, there. Good. Let's show us, Wheel of Fortune out with Family Feud with a big X and the burn. I wish I had that like automated to y'all's test, like every time you answer the question, message.
Oh, it sounds like
What would it sound like in here?
It would sound like
Multiple choice test?
it would sound like 50 basketball games just ended all over. It's like the pipe song.
Yeah, it looks like, what's it called, like Morse code, is that what?
No,
Yeah.
it sounds like a phone just ringing. It sounds like an alarm.
All right, everybody good with that? We'll see some more resonance later on. Everybody good with the allotrope concept?
Yes.
All right, let's kind of take a little different approach here. We'll end up back at resonance in just a minute. Polyatomic ions. You don't remember?
Well, I know what they are, but I couldn't tell you all for 30 seconds.
What's Oxford?
Why is that always the one you go
I don't know.
to? It's
It's
probably the only one you remember.
No, it's the one I struggle with.
Like C2, C2, or 2 minus.
No, I'm
I remember,
genuinely
it's like,
The one that I Me too, and then.
I always thought it was like common.
Take about 5 minutes and draw the structure for hydroxide, hydronium, cyanide, and carbonate. And just remember, okay, that you have to, when you're adding up, the only thing you do different, there's two things, one at the very beginning, one at the very end, that you do different all the time. At the very beginning, when you're adding up the total number of electrons, you have to account for the charge. Okay?
Hydronium is H3O plus.
Yes. And at the very end, you have to put square brackets around the drawing and the charge in the top right-hand corner. All right, about 5 minutes. Knock that out.
Yes.
Mr. Cannon, she's acting like we're in the library.
She's doing what?
She's
Oh,
acting like we're in the library.
it's just.
Yep, like she don't need to be just.
Hydronium.
Stop, you can't yell at me, it's like me, just mine.
Is it CO3 2 minus or 2 plus?
My elemental. Ow.
Is that what I said?
Who's the the tree?
What could possibly be?
You don't even know.
OH one is
You probably do, it's actually.
Probably do.
That's hilarious. I know. She doesn't remember the basics of chemistry. Did you go back to the test? What'd you make? Yeah. What's your height? I make a good guy. That's not my fault. You told me.
Yeah, play with the electrons. Yep.
Can I keep falling either too short, or too below?
What?
I keep either getting too above or too below. It's like I'm right there.
You get what?
I keep either getting two less electrons or two more.
Oh,
It's right on the tip.
counting thing.
It's right on the tip of my toe. I got all the other ones. Aren't you proud?
I am. Ecstatic.
I love the sarcasm.
Oh, I forgot something.
Why'd you draw the second one like that?
Because he would.
How'd you want me to do it?
I don't know, I didn't draw it like that. That's
I
weird.
drew a trigonal.
I mean, there's
I mean,
like,
it is-
there's still like
I look
three
at trigonal
branching out, but
pyramid,
like,
you know. It looks the
looks
same.
more
It's the
like a
same
T.
thing though.
It's the same thing.
Yeah,
I
it
bet you
is.
do it like this.
You're
Yeah.
so good at guessing.
You're so good at guessing.
You would guess it's wrong.
Okay.
That makes a whole lot of sense.
So the only one that I got wrong was cyanide.
Really?
Yep,
Really?
yep.
Really?
Yep.
Sure.
I got carbon.
Nope. Sure, you are.
I got them.
Okay. Technically, I only got.
You're like this.
Wherever you did like the first one.
Oh no.
Yeah.
I was thinking I wanted to.
This one, I didn't pass the third one because I
That was not.
Like, you did like,
No.
like,
Which one are you talking about?
what you did before that, before you changed it.
We leave in like 1 minute.
Same thing.
And I know, like, why did you do it that way?
Okay, real quick, do this for me. Do this for me. I got like a minute, right?
Yes,
Okay,
sir.
real close. Pay attention here.
Okay.
So I forgot to ask you what the geometry of ozone was, so figure that out tonight. What is the geometry of ozone? Figure out the geometry of hydronium and the geometry of carbonate. And is that the right answer for carbonate?
Oh, we did. Resonance structures.
We didn't decide what its geometry-
Sorry. Ozone, hydronium, and carbonate?
Uh-huh. So what, is that the right answer for carbonate though? No, what would the right answer be?
Yes, you have to draw all of those.
There's 3 resonance structures, right?
Oh,
So draw all the resonance structures of carbonate
And I put the arrows.
and then figure out what its geometry is along with hydronium geometry and ozone. We'll pick up there. Well, I won't see y'all tomorrow. Oh, I won't be here Monday either, by the way.
Oh, no.
Who's gonna be in here?
Are we learning any more new content before the test next Thursday, or is it just?
I say let's not have it. Yeah, we get some good stuff. Okay, next.
He can't pick. Or anyone know where Miss Patty is?
Mr. Caleb, if I got a small.
Is she here?
She's probably on Facebook.
No, she literally is.
You're serious.
She got like bullied on Facebook.
That's sad.
How about it?
Oh,
I mean, we were about water.
okay, to be fair, I was about to make that mistake.
No, you just like, oh.
I went to correct.
Why are you gonna call me? Did you do everything else right? Or just like?